So next speaker is Tuomas Ketola and Thomas Rölleke. So they did some work on BM25 on information content-based field weighting for the famous BM25 formula. So stage is yours. Thank you.
Thank you. So hi everyone. So I'm Tuomas, and yeah, I'm talking about the paper I wrote with Thomas, who sends his regards and apologies that he couldn't make it here today. First, I'd just like to thank the organizers for the opportunity. It's my first ever paper, so any comments or insights will be greatly appreciated. So the title is BM25-FIC, Information Content-Based Field Weighting for BM25. In terms of the presentation, I'll just start with a kind of quick, really high-level introduction into the area that I'm talking about. Then we'll talk about the two contributions that the paper makes, after which I'll introduce the BM25-FIC model in detail, and also the kind of interactive model that we've extended the BM25-FIC to. And we'll just finish with a summary and some conclusions. So at a very high level, in kind of many applications, there's this, not problem, but an issue where a score is calculated as a weighted sum of some subscores. It doesn't have to be scores, it can be utility or loss or anything, but in general, this kind of weighted sum is something that appears a lot around the place. So in IR, you do often talk about scores, and the BM25F is an example of this kind of aggregated score. So then the really high level research question that we're tackling is, how do we estimate these weights for the weighted sum? So the approach we've taken is kind of probabilistic / information theoretic, and it's been heavily inspired by IR and even more specifically by the IDF. So move on to the contributions. So the first contribution is this BM25-FIC model, which is basically BM25F with some stuff on top about information content. So the kind of main new thing about the model is the way in which the field weights are calculated, which is this kind of IDF-inspired informatic theoretic approach. Another kind of central thing to the new model is that the field weights are document specific, meaning that, say, document 1 can have a high weight for the title, when document 2 might have a low weight for the title. The second contribution is an interactive model where we use our model together with a seed document as a reference point for re-ranking the search results. And the re-ranking is done based on the similarity of the field weights that the model gives us. So moving on to the actual model. Like I said before, the main thing about this new model is the way in which the weights are calculated. So it's quite evident if you compare the first equation, which is the new model, to a kind of general aggregated score approach, where we just take the weighted sum of the field-specific BM25 scores. The only difference between the two equations is that in the top one, the field weight is a function of quite a few different things, rather than just a kind of constant value that's applied to every document in the same way. It's worth mentioning that the actual BM25F, of course, isn't this kind of aggregated score. BM25 score is there, the weights are actually applied to the raw term frequencies rather than to BM25 scores, but this is as a detail. So then, how do we actually estimate those weights? So the field weight of a field, say the title of a document, is defined as the negative sum of the raw probabilities of query terms occurring in a document field, which is quite a mouthful, but is not too complicated. Is you take all the terms, all the query terms that appear, say, in the title of the document. You estimate the probability for each of those terms occurring in that document. You take their log, sum it all together, and take a negative value, and that gives you the estimate of the field information content for that title of that document, which is then used directly as the field weight. So the actual kind of estimation part of the model comes in when we talk about the probability of a term given a document field, so say a title. And this is estimated by using document frequency of a term. So in this case, say it would be how many times a query term, in how many titles, using titles as an example of a field, how many titles does a query term appear in? And then that divided by what we call NP, which is the number of potential document fields the term could appear in. So number of titles the term could be in. And for this NP, we use three estimates. So the first one, NP1, is just simply the total number of documents in the collection. So the query term could appear in every single document of the collection. Second estimate takes into account the fact that fields are quite often empty when you talk about multi-field retrieval. So there, NP2 is defined as the number of documents in the collection that actually have title. So obviously title can be any field, but title is quite a good example. And then the third estimate basically normalizes NP2 according to the average field length. So the field title tends to be on average shorter than, say, the body of the text. And we want to therefore boost the title a bit to give it higher weights in general, which is shown to be quite a good idea in previous research. So moving on to kind of the results we have. These are all done on a kind of small test collection, which is based on the product catalog of Home Depot. This is used in other research as well. So the relative improvements in the table are calculated against the BM25F micro, which is Robertson's BM25F. The relative improvements are quite big. One of the reasons for that is probably that we use uniform field weights for the baselines, meaning we don't optimize the field weights for those baseline models. One reason for this is that in order to do that, you need some kind of heuristical analysis, or you need some kind of learning process that's based on known relevance information. Since the BM25-FIC model doesn't use either of those two, we also didn't use them for baselines. Obviously, in the future, we plan on comparing the model to kind of more advanced baselines to get a better idea of how it actually performs in general. One point was that using relative improvements for MAP was brought up in the reviews as a problematic issue. There'll be a more detailed query-specific analysis in the future, so it's subject for future work. So we can kind of go beyond averages and especially relative improvements in averages, which is problematic in itself. So the interactive model is basically takes the BM25-FIC score, and then we add a component for the similarity of these field weights between a seed document and the other documents. This means that by adjusting alpha in the equation, a user can kind of navigate the results in terms of query intent. I'm running out of time. I'm not going to go into too much detail on this, but in the paper is explained in depth, and there's a nice example with Harry Potter as well that should kind of clarify how exactly a user can navigate the dimensionality of relevance and query intent and everything. So yeah, it's better explained in more detail in the paper. So to summarize, estimating weights using field information content seems like a very promising approach, which also potentially has application in other areas. Something like data fusion and rank aggregation come to mind, for example. The main contribution of the paper is this new model, which is an automatic method for the estimation of field weights using field information content. Results in a small test collection, they're very promising, both in terms of the baselines and also existing research that uses the same test collection. However, the kind of results aren't comparable one-to-one because you can't really know exactly which queries that other research used, but in general, it seems that our model is doing quite well. And the second contribution is this interactive model that uses these BM25-FIC field weights. Yeah, that's all from me. If there's any questions, I'm more than happy to answer.
Thank you very much. Yeah, are there any questions?
I have a couple of questions.
Okay.
One, what if you don't have fields? And the second question, do you think that dealing with term dependencies can be useful in your BM25-FIC?
Sorry, could you repeat the first questions? There was a slight cutoff.
Yeah, what if we don't have fields?
So in that case, so I kind of came up with the model for the problem of realizing that more and more data is becoming more field-like and there's more HTML rather than just raw books, for example. But off the top of my head, I guess you could do some kind of parts of text analysis, for example, to figure out what is kind of, if you have a long text, what is the kind of introductory part for that text, what is the kind of factual bit, what is the conclusion, and then you could weight between those. So kind of artificially creating the fields, I guess would be one approach.
Yeah, actually, I wonder, as a BM25F and also your approach is based on the quality of fields. Indeed, the weight given to the field means that you are assuming that there are fields of different quality and then fields of high quality. So my question is, okay, we can use passage retrieval, text segmentation, NLP, part of speech tagging. So mine is basically a curiosity, as you addressed the BM25F at large. So I wonder whether you have a general opinion regarding the necessity of high quality fields.
Absolutely. So I think it's exactly right. So high quality field, you could think about a title as being a high quality field because there you have all the important words squished together. So you consider that maybe a more high quality field. However, kind of, for example, in the data set that I used, instead of title, you get kind of product name and product description, where both are of interest to you, but they're not kind of a shorter version of each other. Not always, at least. But still the product name does come up in the query sometimes. So it's kind of not necessarily a quality difference in quality, but actually a difference in the information content of the field that then the BM25F tries to capture, which obviously becomes harder than to have kind of a one weight for one field every time, because queries sometimes have the product name and sometimes they don't.
Okay, the other question was about term dependencies. So
for
do you think that these are useful?
Sorry?
If they are useful.
I think in terms of kind of BM25 in general and these kind of probabilistic, I think they're like most likely would be very useful, but quite difficult to capture. So in this model where you could, it's almost, maybe this would be the dependency of the fields that you could capture when you kind of, because we're basing the field weight on the probability of terms in a field. So maybe you could, yeah, you could take, actually that would be, you could take into account there. So you could, for example, instead of you could estimate the probability of a score of a field rather than the probability of terms appearing in the field.
Okay.
Might be one option, but
Thank
I have
you.
not thought about that very much yet, but it's a very good point.
It's not easy, so thank you.
Okay. So thank you very much. Are there any other questions? If not, I think we should move then to the next speaker. So Tuomas, thank you very much for your talk and
thank you very much
for your
time.
paper. Yeah, so again, a round of applause and on behalf of everyone. So